myself P. Praveena. I am the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today our topic is Convolution Theorem. This is the topic related to the Laplace transforms and inverse Laplace transform. Okay, what is Convolution Theorem? If f of t and g of t are functions defined for t greater than or equal to 0. Where that functions are defined? If t greater than or equal to 0, then Laplace of f of t star g of t is equal to Laplace of f of t star Laplace of g of t. Okay, this is the convolution theorem transformation of that. Laplace of f of t star of g of t is equal to Laplace of f of t star Laplace of g of t. What is the main use of convolution theorem means? Convolution is useful for obtaining inverse Laplace transform. Convolution theorem is useful for obtaining inverse Laplace transform, okay, of product of two transformations or product of two transformations for solving ordinary differential equations. Okay, once again, convolution theorem is useful for obtaining inverse Laplace transform for the product of two transforms. The two transforms are useful for solving ordinary differential equations. Okay, this is the main use of convolution theorem. Okay, how to define convolution? Okay, the convolution of two functions. The convolution of two functions f of t and g of t is defined as f of t and g of t is defined as f of t star g of t is equal to integral of 0 to t f of u g of t minus u du. How to transform here? F of t star g of t is transformed to here integral 0 to t f of u g of t minus u du. This is the formula for the convolution theorem. Okay, now I'll explain that concept on that related problems. Okay, using convolution theorem, find Laplace inverse of 1 by s plus a into s plus b. Okay, using convolution theorem for finding Laplace inverse of 1 by s plus a into s plus b. Here, what are the functions in the given question? 1 by s plus a and 1 by s plus b. Okay, by using convolution, now we have to find out that value. Okay, here we know that from the theorem and from the theorem statement and from the convolution theorem definition, we know that Laplace inverse of f of s dot g of s is equal to what? Dot or star. Okay, is equal to, okay, Laplace of f of s star Laplace of g of s. Okay, once again, that is Laplace inverse of f of s into g of s is equal to Laplace inverse of f of s star Laplace inverse of g of s. From the given question, how to that? That is Laplace inverse of 1 by s plus a into s plus b is equal to, simply I'll write that as, okay, by using the above condition, Laplace inverse of 1 by s plus a, okay, star Laplace inverse of 1 by s plus b. Okay, Laplace inverse of 1 by s plus a star Laplace inverse of 1 by s plus a. But from the formulas of Laplace inverse of 1 by s plus a means, what is the formula for that? E power minus at. What is the formula for that? E power minus at. And Laplace inverse of s plus b means what? E power minus bt. Okay, e power minus bt. Let us assume the two are, okay, first term e power minus at as f of t and e power minus bt as g of t. Okay, now I'm assuming that as f of t and g of t. Okay, therefore, but from the convolution theorem, f of t star of g of t is equal to what? By using convolution theorem, this is the formula for the convolution theorem. That is f of t of star g of t is equal to what? Integral of 0 to t f of u into g of t minus u du. Okay, but from the above one, f of t is equal to e power minus at and g of t is equal to e power minus bt. E power minus at, g of t is equal to e power minus bt. From that, I'll assume that as f of u. What is f of u here? E power minus au. And what about g of u? E power minus of bu. But here, what is the form of g of t minus u form? That's why I'm writing simply that as g of t minus, this is no need. Okay, g of t minus u is equal to, in place of t as, I'll write t minus u. That means g of t minus u is equal to what? E power minus b of t minus u. E power minus b of t minus u. Therefore, here integral, how to convert that? Integral 0 to t e power minus au into e power minus b of t minus u du. Okay, now I'll subtract this one as e power m minus n formula. That is e power m into e power minus n. That is integral 0 to t e power minus au into e power minus bt. Here minus into minus plus, simply that as e power bu into du. Here, okay, what is the constant term with respect to the integration with respect to u means, now I'll take e power minus bt as the constant, or I'll take that as an outside. That is e power minus bt, I'll take it outside, and the remaining as integral 0 to t. What is the form of that? Here e power minus au, I'll write simply that step here, integral 0 to t e power minus au into e power bu du. Here outside is e power minus bt. Okay, that is simply I'll write here. Okay, bases are equal, then we should add powers. That means e power of minus au plus bu du. E power minus au plus bu du. That is equal to e power minus bt into integral 0 to t. Here in the powers, which term is common? U is common. Then I'll take that as common. That is e power of, I'll take minus also outside with u. Okay, I'll take minus u outside, and the remaining part as a minus b into du. A minus b into du. Now integrate with respect to u. Okay, then what is the formula for that integral? E power x integration is, okay, here e power minus bt into, okay, that integration is e power of minus a minus b into u by, what is the u coefficient here? Minus of a minus b. Okay, minus of a minus b. And after the integration, what are the limit points here? 0 to t. Okay, here the limit points are 0 to t. By using convolution theorem, now we have to convert the function, and after that integration with respect to u, then we got e power minus bt into e power of minus a minus b into u by minus of a minus b. Okay, limits are 0 to t. Now I'll substitute the limit points. Okay. Okay, what are the upper limit there? Upper limit as t and the lower limit as 0. Okay, then I'll substitute that limits here. That is e power minus bt into, okay, e power minus bt into e power of minus of a minus b into t by minus of a minus b. Okay, minus of here, what about the e power 0 value? E power 0 value is 1. I'll explain clearly here. Okay, e power minus bt into power minus of a minus b of u by minus of a minus b. I'll substitute the limit points here. That is e power of minus bt into e power minus of a minus b of 0 by minus of a minus b minus in place of t, what are the lower limit here? 0. Therefore, e power minus of a minus b into here t and here 0 by minus of a minus b. Okay, this is in power that 0. After that, this is e power minus bt into e power of minus a minus b into t by minus of a minus b. Here once you observe, here e power 0 form. Okay, numerator is in e power 0 form. Therefore, e power 0 value is how much? 1. That is 1 by minus of a minus b. 1 by minus of a minus b. Therefore, here that is e power minus bt into, here what is common? Here what is common? I'll take a minus b as common. Okay. Okay. This is this step. Okay. After that, here I'm taking a minus b common. Okay. And a minus b common after that here. Okay. Then the remaining part as 1 minus. 1 minus, okay, e power of, here minus into minus plus, here minus into minus plus, already I'll take a minus b as outside denominator part, that's why here I'll write 1 as first term, that is 1 minus e power of minus at into e power of bt. 1 minus e power minus at into e power of bt. That is here, after that, okay, I'll take e power minus bt inside the brackets. E power minus bt I'll take inside the brackets, that is 1 by a minus b into e power minus bt minus e power minus at into e power minus bt into e power bt. That is 1 by a minus b into e power minus bt minus of e power minus at. Here bases are equal, then we should add powers, that is e power minus bt plus bt as 0. Therefore, e power 0 value is how much? 1. Okay, that is 1 by a minus b into e power minus bt minus e power minus at. Therefore, for the first question, okay, by using the convolution theorem, Laplace inverse of 1 by s plus a into s plus b, answer 1 by a minus b into e power minus bt minus e power minus at. Okay. This is the first question answer. Next one. Okay. Using convolution theorem, find Laplace inverse of 1 by s into s square plus 1. Okay. Using convolution theorem, then find Laplace inverse of 1 by s into s square plus 1. Same as previous question. Here also two functions. One is 1 by s and the another one is 1 by s square plus 1. By using the convolution theorem definition here, Laplace inverse of f of s into g of s is equal to what? Laplace inverse of f of s star Laplace inverse of g of s. Okay, therefore, for the given question, Laplace inverse of 1 by s into s square plus 1 is equal to Laplace inverse of 1 by s. Here, this is star. Laplace inverse of 1 by s square plus 1. Okay, therefore here Laplace inverse of 1 by s value by using the formula. Laplace inverse of 1 by s is equal to 1 star Laplace inverse of 1 by s square plus a square formula. That is directly here a is equal to 1. For that case directly formula sin t. Okay, therefore Laplace inverse of 1 by s star Laplace inverse of 1 by s square plus 1 is equal to what? 1 star sin t. Simply I'll write that as sin t star 1. Okay, therefore by using convolution theorem here, okay, that is, what is the theorem statement here? Integral 0 to t f of u g of t minus u du. Okay, this is the convolution theorem, okay, formula. From that, here what is f of u? From the above step, f of u is equal to 1 and g of t minus u is equal to sine t. Okay, that is general. Why? Because I'll write this as 1 into 1 star of sine t, means in that f of u is equal to 1, g of t minus u is equal to sine t. But our convenience, I'll write 1 star sine t as sine t star 1. Sine t star 1. Okay, both are same only. Okay, then here from this condition, what is f of u? F of u is equal to here sine u. And what about g of t minus u? That is equal to 1. Okay, here g of t minus u is equal to 1. Then substitute both the values in the above formula, that is integral 0 to t sine u into g of t minus u is equal to 1. That is 1 into du. Okay, that is integral 0 to t sine u du. Okay, this is this step. Integral 0 to t sine u du. Okay, easily we got the value for this, integral 0 to t sine u du. And what about sine u integration with respect to u? That is minus cos u. Okay, sine u integration is minus cos u and the limit points are 0 to t. Okay, and the limit points are 0 to t. Therefore, substitute the limit points here. Upper limit is t and the lower limit as 0. Then substitute here minus cos u. Minus cos u means upper limit as t. Substitute here minus cos of t minus of, okay, here I'll write the step here. That is minus cos t minus of minus cos 0. That is minus cos t minus of minus 1. That is minus cos t plus 1. Minus cos t plus 1. Simply I'll write that as 1 minus cos t. Therefore, the second question, by using convolution theorem, Laplace inverse of 1 by s into s square plus 1 is equal to 1 minus cos t. Okay, this is the second question answer. These two are very simple questions. Next, I'll explain one more question on the convolution theorem. That is, using convolution theorem, then find Laplace inverse of s by s square plus a square whole square. Okay, using convolution theorem, find Laplace inverse of s by s square plus a square whole square. Same as previous questions only, but it is difficult compared to the both the questions. Why? Because once you observe the last two questions, from the last two questions there is no, okay, numerator part. Okay, there is no numerator part in the question, but here in the third question, okay, numerator part as s by and denominator as s square plus a square whole square. Okay, for that case, how to solve, I'll explain clearly here. That is, by using convolution theorem definition, f of t dot, okay, g of t is equal to what? Okay, already we know that f of t dot, okay, that is simply Laplace inverse of f of t dot g of t is equal to what? Laplace inverse of f of t star Laplace inverse of g of t. Okay, this is the convolution theorem definition. From that, here first I'll separate the, okay, terms here. From that, Laplace inverse of s by s square plus a square whole square is equal to, I'll write that as, okay, Laplace inverse of s by s square plus a square whole square is equal to Laplace inverse of s by first part as s square plus a square star Laplace inverse of, what about the second part from the equation? Here from the equation 1 by s square plus a square. Here the second part of the question as 1 by s square plus a square. Okay, this is this step. Therefore, here Laplace inverse of, which is in the form of Laplace inverse of s by s square plus a square star. Okay, here what is missing term? Okay, I'll multiply and dividing with a. Okay, here I'll multiplying and dividing with a. Why? Because if you are multiplying and dividing with a, then the function will be converted in terms of, okay, sin a formula. Okay, now that's why here I'm multiplying and dividing with a. Therefore, Laplace inverse of s by s square plus a square star 1 by a into Laplace inverse of a by s square plus a square. Okay, directly we know that from the inverse Laplace transformation formulas. Okay, that is Laplace inverse of s by s square plus a square is equal to what? Cos at. And here 1 by a into Laplace inverse of a by s square plus a square, that is 1 by a outside, and this is a by s square plus a square, that is sin at. Okay, therefore I'll take 1 by a outside and the remaining part as cos at star sin at, cos at star sin at. Okay, by using convolution theorem definition, up to now we got 1 by a into cos at star sin at. Next step. Okay, but from the theorem statement, f of t star of g of t is equal to what? F of t star of g of t is equal to integral 0 to t f of u g of t minus u du. This is the convolution theorem statement. From that, first now I'll convert the functions are integral 0 to t f of u g of t minus u du. Okay, that is here what is f of t from that? Here f of t is equal to, here f of t is equal to cos at. And what about g of t sin at? G of t as sin at. From that, but here from the theorem which is in the form of g of t minus u. That's why I'll write here g of t minus u is equal to sin a of t minus u. Here, what is f of t? F of t is cos at only, and g of t minus u is equal to sin a of t minus u. That's why I'll write simply from the above step 1 by a I'll take outside and the remaining integral 0 to t cos au. Okay, here f of u is equal to what? Cos au, and g of t minus u is equal to this one. Okay, therefore substitute here, that is integral 0 to t cos au sin a of t minus u du. Okay, 1 by a integral 0 to t, here cos au I'll take inside the brackets a, that is sin at minus au du. Okay, which is in the form what? Okay, here once you observe here, what is the formula of that? Which is in the form of 1 by a into integral 0 to t cos a into sin of a of t minus au of du as, okay, which is in the form of 2 cos a sin b formula. Okay, 2 cos a sin b formula. That for that, what is the formula of that 2 cos a sin b formula? 2 cos a sin b formula here. Okay, that is sin a plus b plus sin a minus b. Sin a plus b plus sin a minus b. 2 cos a sin b formula there. Sin a plus b plus sin a minus b. That means here I'll multiplying and dividing with 2. Okay, from the above step here I'll multiplying and dividing with 2. Here 2 integral 0 to t 2 cos au sin at minus au du. Okay, that is 1 by 2a, that is 1 by 2a into integral 0 to t. What is the formula for that? Sin a plus b plus sin a minus b. Here what is a from this? Au. Okay. Au. That is sin au. Okay. And plus, what about b here? At minus au. At minus au. Plus sin a minus b, that is au minus of, okay, minus of at minus au into du, that is 1 by 2a into integral 0 to t, okay, 1 by 2a into integral 0 to t sin, here a minus au plus au cancel, that is sin at, plus here sin of au minus at, minus into minus plus au into du. Okay, from that 1 by 2a into, okay, 1 by 2a into integral 0 to t, okay, sin at plus sin of, here what is common here? Okay, first I'll take au plus au as 2au minus at into du. 1 by 2a into integral 0 to t sin at plus sin 2au minus at du. Okay, that is here. Next step, 1 by 2a into integral of 0 to t sin at plus, here what is common term? A is common. Okay, from that sin of a into t minus 2u into du. This is this step. Okay, 1 by 2a into integral 0 to t sin at plus sin a of t minus 2u du. Now integrate. Okay, after writing the formula of trigonometric, here all formulas are important. Intermediate level, each and every formula is important. Okay, after that, after writing the formula, it will convert 1 by 2a into integral 0 to t sin at plus sin a of t minus du du. Next step. Okay, that is now integrate with respect to u. That as 1 by 2a into integral of sin at and integral of sin a of t minus 2u du. Okay, therefore here integral sin at, that is integral of sin at formula. Okay, with respect to u, is it integrable sin at function? No. That's why I'll write that as sin at and one integration as u. Okay. Plus, once you observe the second part, sin a of t minus 2u du. Here u term is there. Therefore, it is integrable. Therefore, sin a of t minus 2u integration is minus cos of a into t minus 2u by minus 2a. Minus 2a. Therefore, what are the limit points here? 0 to t. Okay. After the integration, now it will convert 1 by 2a into sin a of t into u plus into minus of cos of a of t minus tu by minus 2a. That is equal to here. Now substitute the limit points. That is 1 by 2a into, okay, sin 80. What about the upper point here? Upper limit point as u. Upper limit point as, sorry, t. Upper limit point as t. plus into minus, minus, or directly right here, plus in brackets cos A of t minus 2 into t by minus 2a. If you are substituting the upper point, it will be convert 1 by 2a into sin at into t plus into minus. I'm not writing here. Okay, anyway here minus minus cancel. That's why I'm not writing. And cos a of t minus 2t by 2a minus of. Now substitute the lower limit that as yeah, minus minus cancel, that as sin a t into 0 minus of cos a of t minus 2 into lower limit as 0 by 2 into a. Okay, now we are substituting upper limit and lower limit points here. After that 1 by 2a into 1 by 2a into t into sin a t. Okay, here plus cos a of t minus 2t. If you are subtracting both, t of minus 2t means what? T only. And cos at. It is cos at by 2a. Cos a of minus t. But what is the formula of cos of minus theta? That is plus cos theta. That means I'll write here directly cos at by 2a. Cos at by 2a. Okay, then minus of here, this is completely 0, minus of cos at by 2a. This is this step. Okay, that is 1 by 2a into t sin at plus cos at by 2a minus of 0 minus cos at by 2a. Okay, here next step 1 by 2a into t sin at into sin at plus cos at by 2a. Okay, and here minus cos at by 2a. Once you observe here this is plus this is plus. Why? Because here cos a of t minus 2 of 0, that is cos at by 2a. After substituting here the limit point, it will convert this as minus. That is 1 by 2a into t sin at plus cos at by 2a minus cos at by 2a. Once I'll check here, once you observe, if you are substituting t and 0, cos a of t minus 2u, that is cos minus t by 2a. Cos a of t minus 0, that is cos at by 2a. That means one is plus and the one another one is minus. Okay, there plus, sorry, here plus. Okay, now it is correct. Okay, then 1 by 2a into t sin at plus cos at by 2a minus cos at by 2a. Therefore, these two are cancelled. Therefore, these two are cancelled. Therefore, here the final answer, okay, there the final answer is 1 by 2a into, okay, t sin at. 1 by 2a into t sin at. Is there any confusion here? Once again, I'll explain here. Here, 1 by 2a into sin at into u plus, okay, here minus minus cancel. Minus minus cancel. That's why here we got plus. Okay, that means 1 by 2a into sin at of t plus cos a of t minus 2t by 2a minus sin at of, we are substituting the lower limit, that is 0. Here plus only, not minus. By mistakenly I wrote here, that is plus cos a of t minus 2 of 0 by 2a. That is 1 by 2a into t sin at. Cos a of t minus 2t means here we got cos a of minus t. Cos of minus theta is equal to what? cos theta. That's why I'll write here cos 80 by 2a minus of sin 80 of 0 means what? Sin of 0 means 0 with multiplied with anyone, that as 0, plus cos a of t to 0, that is 0. That means simply that as cos 80 by 2a, that is cos 80 by 2a. Therefore, 1 by 2a into t sin 80 plus cos 80 by 2a minus cos 80 by 2a. That means one is negative 1 and one is positive 1. Therefore, both are cancelled. Therefore, we got the final answer for this 1 by 2a into t sin 80. 1 by 2a into t sin 80. This is the final answer for the third question. It is very difficult compared to the previous questions. If you know each and every formula in intermediate level trigonometric and differentiation and integration, for that case only these type of problems are easy. Otherwise it is very difficult to solve. Okay, this is the final answer. Therefore, Laplace inverse of s by s square plus a square whole square is equal to what? 1 by 2a into t sin 80. Okay, therefore, today how many questions we discussed? 3 questions. Okay, 3 questions by using convolution theorem only. This topic is very, very important in that chapter. Okay, this is, and the third question, okay, compared to the last 2 questions, third question is important. Okay, okay, thank you. And next class we will discuss some other topics on Laplace transform. Thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.